daily life also. In our daily life also, this gravitation has so much important in our practical life. If gravitational force is not existing, then the solar system cannot be stable. Means all the planets cannot revolve around the sun in their particular orbit. If gravitational force is not present, all the planets fly away from the solar system, then there will be no solar system. And then on the earth also, if on the earth's surface no gravitational force exists, then no objects can be stable on the earth's surface. All the objects will fly away, right? And all the gaseous particles move away from the earth's surface. And then if there is no gravitational force on the earth, the rainfall cannot occur. That means the water droplets cannot move downwards. They move away. They move in the upward direction. So there are so many importance of this gravitation. Right. After this gravitation, now we are going to discuss one more term, that is gravity. It is gravity. There is not much difference between gravitation and gravity. Gravity is actually what? It is the force exerted by the earth on the other object. Suppose we take this is the earth. Earth, and earth is also attracting every object around it. Suppose we put any object. Its mass is m. Let us take the mass of earth is capital M. And both the masses are very much differing. So the mass of earth is very larger than mass of the object. Still they are exerting force. That is on the basis of that Newton's law of gravitation, that every object in the universe attract each other. Here the small m, it is attracting the earth. Earth also attracting the mass of the object, that is small object. So there is force of attraction between the object and the earth. Object and the earth. Here also the force of attraction. Here the force exerted by earth on any other object is known as gravity. That is the gravity. Otherwise, this is also the gravitation, because the object, the earth, the object, everything can be considered as the celestial objects. So the force between the celestial objects, gravitational force or gravitation. But specifically we are mentioning that the force exerted by earth on other object is the gravity. So due to this gravity, all the objects are attracted towards the center of object, because the gravitational force is acting towards the center of earth. Here the object is attracted towards the center. Wherever we put the object, they are always attracted towards the center of object. Right? Okay. In all the cases, both the forces, both the objects, earth and the other object, they exert force on each other. So we can say Newton's third law of motion is applicable here. Newton's third law of motion, it is applicable everywhere. I told in the last chapter also. Right. So now what happens to the objects due to gravity? Here the object is attracting the earth. Earth is attracting the object with the force F. That means force exerted by object, force exerted by earth, they are equal. Because Newton's second law, every action there is an equal and opposite reaction. So the force is equal. Due to the equal force from the Newton's second law, F equal to ma, then this force is constant. From this we can say m into a equal to constant. If m into a equal to constant, then a proportional to 1 upon m. It means the mass of object and the acceleration produced in that object are inversely proportional when the force is constant. Here you see the mass of earth is very larger compared to the mass of object. Therefore, the acceleration is inversely proportional. The acceleration produced in the object is very larger compared to acceleration produced in the earth. That's why we say the earth remains at rest. But actually what is happening? Earth is also moving towards the object. Since both are attracting each other, both are moving towards each other, because of its mass, we do not feel its motion, right? So the acceleration produced in the object towards the earth. That's why every object is moving downward. Every object is moving downward towards the earth. And during that motion, during that force of attraction towards the center of earth, the acceleration is produced. Suppose this is the object. Its mass is m. It is accelerated towards the center of earth. In this case, the acceleration is produced. That is known as acceleration due to gravity. It is acceleration due to gravity. And it is given by the symbol. Acceleration due to gravity is written by the symbol cap small letter g. So we are using both the letters. Capital G, it was gravitational constant. Small g, it is acceleration due to gravity. So what is acceleration due to gravity? The acceleration produced in an object when it is moving towards the center of earth, when it is attracted towards the center of earth, that is acceleration due to gravity. It is given by the symbol g. Since it is the acceleration, its unit is meter per second square. Its unit is meter per second square. This acceleration is always towards the center, is always acting towards the earth. So therefore, whether the object moves upward or downward, it doesn't matter. It is always acting vertically downward, that means towards the earth. Therefore, we say acceleration due to gravity is vector quantity. It is vector quantity. Capital G, it was a scalar quantity. This is vector quantity. Capital G unit Newton meter square per kg square. Its unit is meter per second square, since it is the acceleration. So like this, every object when it is placed above the earth's surface, it is attracted towards the earth and moves with the same acceleration. All the objects, suppose its mass is 1 kg, it is falling downward with an acceleration g. If you put the 100 kilogram of object, 100 kg of object, it is also attracted towards the earth, then also the acceleration due to gravity is same. For all the objects, the acceleration due to gravity remains same. So that means the acceleration due to gravity produced in any object is independent of its mass. Its mass. That what is the mass of object, whether the mass is 1 gram, 1 kg or 100 kg or 1000 kg, whatever be the kind of object which is moving towards the earth's surface, their acceleration remains same. It is not depending on the mass of that object, but it depends on some other factors. That factors on which the acceleration due to gravity that can be obtained from a simple relation, from a derivation. Let us see that derivation means that relation on which the acceleration due to gravity depends. For this, we are going to take the earth as an exactly spherical body. Suppose this is the earth and we consider the earth is exactly spherical. So its mass is capital M and this is the center of earth. So this distance, it is equal to radius of earth. So mass of earth, it is also calculated by some method. It is equal to 6 into 10 power 24 kg. Radius of earth, it is also calculated 6000. This is average radius, not the exact value. Average radius 6400 kilometer. That is equal to 6.4 into 10 power 6 meter. Right? This is the average radius. From the earth's surface, if you put any object at some height. Now this is the object. It is placed at some height above the earth's surface. That is, the mass of object is taken as small m. Now this object is attracted by the earth. Due to that, the object moves downward, and that force of attraction with which the object is falling, with which the object is moving towards the earth, that is equal to m into a. From the Newton's second law, that is m into a.